Okay, so today we're going to be working on writing and solving equations in context. Really what this means for us is we're going to be doing two-step equations. Let's see if I can make this bigger. There we go. And we got to determine a few things when we set up our equation. We need to define our variable, like we need to figure out what the question is and what we're looking for. We need to find out what the constants are, which one usually represents the total, and there's another one that's smaller. And then we gotta figure out what the rate is, and then we'll write our equation using that information. That's the way it worked out for all of our stuff today. Let's see, I think it should work out for all these problems as well today. A lot of the cookie cutter two-step equations that students do are in that format, and that should help them out. So what I like to do is define the variable, but we're lucky. They tell us what we're going to use here. Determine M, and it says it's the average number of miles you'd ride each day. So they already defined the letter for us. So we're looking for M. That's what we're trying to figure out. That's our variable. Variable there. And then we got to figure out what the constants or what these other numbers mean. So we've got something here. We've got this that may play into it. And let's see here. He's already ridden 17 miles. Okay, so it's pretty obvious to see what the total is. If you read the question, Carter wants to ride his bicycle a total of 28.7 miles. So we're going to get to that amount. And there's certain ways we're going to get there. We've already traveled 17, so we're already partway to that total. And now we just use the rate times the variable. Well, we know our variable is M. It's given to us in the equation. In a way, this is a little bit easier than what we did yesterday because they define the letter, they give you the letter, and they define it already for us right there inside of it. So the rate would be how many miles. M represents the average number of miles you ride each day, and we're going to ride for 3 more. So that is the rate, 3 more. And all the time, the rate number should be linked to the variable. So in a way, like, so for example, if he travels an average amount of miles, like 4 miles a day, and it's 3 more days, they go together. So at this point now we're just going to solve the equation. And for us, each time it's going to be pretty much the same. You're going to deal with the constant first, and then second, you're going to deal with the coefficient on our letter. And we use a series of opposites. For example, we have a positive 17 on this side. We're fighting to get this letter by itself, and we've got to eliminate that number and that number to get the letter by itself. So we use a series of opposites. So we'll opposite the 17 on both sides. Sometimes students make this a little messy, so I said bring down your equal to symbol, keep it even. This should be, I think it's 11.7, and we have 3M here. I don't know what 11.7, something a little less than 4. Divide that by 3. Divide by 3, divide by 3. There's that second step. It's 3 times M. It's understood multiplication. We're going to divide. So M is 3.9. I don't think they mentioned about rounding, so we'll say it's 3.9. I'm going to clear the work and just click on the button to see if we get this right. Show solution. That is a little overly complicated. Let's see, they got 3M plus 17 is 28.7. That's the same equation we had. And they did get 3.9. So what they're looking for in the first box is this equation, and then the second box, the answer. And there we go, equation and the solution. Let's see what this one looks like. Okay, did they define the variable for us? Yes, they did. Golly, that is a little bit easier than what we did on Monday. Today's Monday for me, but you're going to be watching this on Tuesday. So we need to determine X, and that represents how much each bottle of juice costs. So our equation will be rate times variable. So it would be something, some rate times the letter x. We're gonna have probably a plus, but it could be a minus. And then here's the total. We gotta figure the total out. So let's look at the other remaining numbers. We've got, well, look, it says total cost. There's this number, that's the total. And then one of the bags costed $207 and a 24 pack of juice bottles. Okay, each bottle of juice. Well, there's 24 per pack. And a bag of oranges was already purchased, $207. And the total was $33.03. Probably should have read this a little more carefully. Let me double check here. He bought a bag of oranges, so he spent that much. That was part of his expenditure. The total expenditure was $33.03. We want to find out how much each bottle of juice costs. So it's 24 per bottle. Yeah. Notice that I said it. Sometimes students, we talk about on Monday that when we look at rate, it's either they use the word per or they use for each, the word each. And even if they don't use those words, if you can talk it out yourself and it fits, then it fits. So if it's 24 bottles per pack, then you use that word in your own speech and you can see it there. So that could help sometimes clarify the confusion when you think it out for yourself. So when we go ahead and solve this two-step, first step is to eliminate the 2.07, which, what happened there? Oh gosh, I'm gonna use my calculator. I don't wanna do all that madness. Well, maybe I will. It's a 10, which becomes a 9, which becomes 13, which becomes a 6, and 9, and then I haven't done this kind of math in a while. Let me double check myself. 30.03, take away 207, 20, what did I do? 33.03. I typed it wrong. 2.07. 30.96, that's good. So you have 24x is equal to that, and then you divide by 24. You divide by 24, it'll give you the price per bottle, which I got 1.29. And you don't have to round that off because $1.29, that's the nearest penny. So you're clear on that. All right, so we got $1.29, and that was the equation. Let's see if they did the same thing or if I have to eliminate this video, start fresh. Let's see, the equation was 24x plus 2.07, $1.29. Yep, it's all. This is the match for the blanks that they wanted. They do some funky stuff up here. That's a little too much. I get what they're trying to do, but that's overly complicated, like 4th grade math. What happened to learning times tables? Okay, let's do one more. Oh gosh, there's some big numbers. We'll do one last one. Hopefully this will get you guys settled. Remember, we're doing the same general thing. You'll take your rate times the variable, add the constant, it equals the total. Yesterday, we stressed defining the variable over and over again in class, which was a bit of a struggle, but thankfully they give that to us here. Determining X, the number of players the team can bring to the tournament. Basically, that's that. Oh, look at this. Per player. I love it when it happens. There we go. So we know that's going to most likely be our rate. The team raised a total. Remember, they raised this much. They spent that much on a bus rental. This is going to be our total. So I know these guys aren't going to have paper and pencil where they were circling the numbers and defining them. Like this thing where I circled it and wrote down that it meant the total. That's what we did in class yesterday. But you're going to do the same thing mentally. You might want to write down some of those things if you need to on your paper. This one is the constant. It's usually smaller. It should be smaller than the total. And that gives us everything we need to write our equation. So it's the rate, 24.75 per player, which X is the number of players. Notice how they're together, 24.75 per player, and the variable goes with it, and it says the variable is X, the number of players per team, or players the team can bring. So those two things will go together if you read them, they go together. together. And then we add our constant, 856.50, and that equals 128, wait, I missed one, 1128.75. All right, so there we go. Now I know these decimals are ugly, but it's just a two-step equation. And, oops, what are we doing? I need that to change color. And we need to get comfortable with double decimals or two decimals on there. I mean, that's how money works, right? And you want to be at least fairly competent with money type equations. For obvious reasons, you don't want to go in debt or make foolish purchases and mistakes. So develop your money sense. Okay, your equal to symbol. I'm not going to fiddle-faddle with the old school math. 8.75. So I'm just typing in that number. I'm going to take away the 856. I hope I did it right. I'm a little tired. I'm running out of gas. That whole thing where you wake up in the morning and run a mile and a half is starting to catch up to me. Okay, lastly we divide. Notice I mentioned at the very beginning, this is going to be your first step. We did the opposite of that on both sides. And then the second step is always going to involve the letter here. And I think all these questions in particular, that's this number times the x, so you'll just do division for your final step. So divide by 24.75. And you don't really have to divide it, you can just use your calculator. Oops. Oh my. Why did I have to type that in? I hit the wrong key. $11. That finger bit. Okay, so we get 11. 11 represents the number of players they can bring to the tournament. That's something anybody has to like. Not everybody would do that problem or think about that kind of problem, but sometimes when I'm doing mental math in my head, when I plan for tournaments and events for the wrestling program, I have to think of things like that. It's like, how much are we going to get per player? Like, is spending this money worthwhile for our team? When you make financial decisions, whether you're leading a program or a household, that can be some of the things you think about. So it should have some value in real life. Let me go ahead and X this out. Hopefully this was helpful for you. Let me double check the answer. I'm pretty sure I did it right, but there's the equation, there's our constant, rate, variable, total, and they got 11. Good to go. You guys have a great day. I'll be at the doctor. They're going to be sticking a bunch of stuff in my knee, so hopefully I'll be okay, and I'll see you guys on Wednesday.